Well, now we're going to talk about basic counting principles. Now, this is not as easy as just counting the number of marbles in a box or something like that, but more how many ways can you do something given some parameters. Maybe you've got 10 blocks and you're going to line them up left to right. How many different ways could you do that? Where every time the blocks are ordered a different way, it gives you a new ordering. And let's take a look at this example. A student is getting ready for class, and he's got a total of 3 pairs of pants, and we're just going to call them P1, P2, and P3. And he's got 2 choices for his shirts, S1 and S2. How many possible outfits could he make, where the outfit consists of just choosing 1 pair of pants and 1 shirt? Well, first, we're going to list all the possibilities. And this is very easy because he only has a few shirts and a few pants and a couple of shirts. But if there were hundreds of them, we're going to need to come up with a formula. But for now, let's just list all the possibilities where you choose 1 pair of pants and 1 shirt. So let's start off with, there's only 3 pairs of pants to choose from, so let's start with P1. Well, if you choose pair of pants 1, how many outfits could you make? Well, you either have to choose S1, that's 1 possibility, or with P1, you have to choose S2. We've now written down every single outfit that uses pair of pants number 1. This and this. I'm writing them like ordered pairs, where the first thing is the pants and the second one is the shirt. So now we've done all of them with P1. If you wanted to, you could put a line through that. Now let's go to all of the outfits that use pair of pants number 2, P2. Well, you only have 2 choices. You have to choose S1, or you have to choose with pair of pants number 2, shirt number 2. And now we've written all of the possibilities that use pants number 2. And now we have to move on to the last one. P3, pair of pants number 3 and shirt 1. Or we could do pair of pants number 3 and shirt 2. And you can easily see we've exhausted every possibility, and now we can simply count them up. 1, 2, 3, 4, 5, 6. So the answer to how many would be 6. Now we're going to look at another way of doing it, called a tree diagram. And you can think of it as, well, here you are in the morning. You're that dot. And the first thing you need to do for this outfit is to choose a pair of pants. And how many options do we have? We've got 1, 2, 3. 3 options. And you could even label the edges. This is called a tree diagram. This will be the root of our tree here. And these are edges connecting to another, what we call a vertex. But let's see, let's label. If you take this path, let's call that pair of pants number 1. This one is pair of pants number 2, and that's pair of pants number 3. Sorry about that. Okay, so we had 3 choices to make. Now, what happens after you make the choice for pair of pants number 1? You've got 2 more choices to make. You can either choose shirt number 1 or shirt number 2. If you chose pair of pants number 2, you have exactly the same choice. S1 or S2. If you chose pair of pants number 3, you get the same choice. It's either S1 or S2. This tree diagram describes every possibility. Notice as you move from left to right, how many endpoints are there on the right? We'll call this the start and this the finish. 1, 2, 3, 4, 5, 6. Just like this. Each one of those paths, if you walk along this one, take the P1 path to the S1 path, this represents P1, S1. This one right here. I won't write all of them down, but let's go down to the bottom one. This bottom path would be pair of pants number 3, shirt number 2, P3, S2, and it would correspond to this one. And you can see that each of these 4 in the middle would correspond to these 4 right here. So 1, let's count up the paths. 1, 2, 3, 4, 5, and 6. So we could have done it either way, really. If all you needed to do is count them, you could have written all of these pairs out, or you could have drawn this tree diagram, and it works every time that way. Now, this is not the most simple way to do it, and we're going to learn a formula to do it, and some of you may already have figured out what the formula is, but let's do one more example with pictures. Let's say that there are 3 roads from city A to city B. 3 roads. And there are 4 roads from city B to city C. How many possible routes are there using those roads from city A to city C? Well, let's simply draw a map. Let's call this city A, call this city B, call this city C. And let's draw out the roads. There are 3 roads from A to B. 1, 2, 3. There are 4 roads from city B to city C. 1, 2, 3, and 4. So now we could go through and we could just count all of the possible paths we could take. Notice if you take the top road, maybe we call that road 1, road 2, road 3, and maybe I'll call these, and let me use a different letter. Let me use S1, S2, S3, S4. One of the paths would be take road 1 and road R1 and road S1 to get from A to C. But look how many ways you have going from R1. If you take path R1, that means you've got 4 more choices to make. If you take R2, you've got 4 choices to make to get to C. If you took R3, you've got 4 choices to make. So next one's going to be a little tougher drawing the tree diagram. I may not label everything. Let's say we start here, and this is like, let me see how much room I have here. I'm going to draw 3 roads, or 3 edges, we'll call them. This is a tree structure. So this is our starting point A. This is going to be our B, and then we're going to have a C over here. The problem is I'm going to have to draw this very small. 1, 2, 3, 4. You have 4 possibilities once you're in city B to go from B to C. And likewise, I'm going to draw 1, 2, 3, 4. And 1, 2, 3, and 4. So that's our tree diagram. Here's your starting point. You've got to take one of the 3 roads. So I put 3 edges coming out of this. This we could call R1, R2, R3. I'm not going to write the labels on all these because they're too close together, but it would just be S1 to S2, S3, S4, S1, S2, S3, S4, S1, S2, S3, S4. So the total number of ways to go from A to C, just count up these. 8, 9, 10, 11, 12. There are 12 different ways to go from A to B and then to C. And you would have counted them up the same number 12 if you'd gone 1. Well, if you take road 1, you've got 4 choices. That's 4. If you take road 2, there's 4 choices. That's 4 more. If you take road 3, you've got 4 choices. That's 4 more. So you have a total of 12 possible ways to get from city A to city B on those roads.